Hi class, this is Professor Latham. I'll be doing a movie on finding the confidence interval for the difference of two population proportions. So we have a problem opened up for us here, so let me slide it so all of it will be on the screen. A comparative study of two new drugs, A and B. 300 patients were treated with drug A, 325 with drug B. The two treatments were randomly and independently chosen, and it was found that 210 patients were cured using drug A, or 211 for drug B. Let P1 be the proportion of the population of all patients cured using drug A, and P2 the proportion of the population of all patients cured using drug B. Find a 90% confidence interval for the difference of the two population proportions. When we go to list of formulas, it'll give us a list of formulas for finding confidence intervals as well as hypothesis testing. At the top here, we see that there's a general formula for finding confidence intervals. It's the estimate plus or minus the critical value times the spread. And if we scroll down just a little bit more, we'll see that the first column gives us the estimate, and the second column gives us what's spread, standard error or the standard deviation. So this is the spread. So you can almost think of the formula for finding the confidence interval would be X bar plus or minus critical value, that's not right there, but the critical value times the spread. That's in the case if we were estimating mu using a confidence interval, but in our case we're not estimating mu, we're estimating the difference of population proportions. So let's scroll down, but notice that's always going to be the general formula. This creature plus or minus the critical value times the spread. So let's scroll down. And we have here estimating the population proportions via a confidence interval. Now we can use the standard z-score when all these proportions are satisfied. So in our problem we'll double check to make sure that's the case. Otherwise you have to use non-parametric methods. However, we don't cover that in our course. So you should, well, hint hint, it'll work. But be careful that you do want to make sure that these proportions are satisfied. All right. So when I click on list of formulas, wahoo, guess what happens? That formula pops right into the ALEKS calculator and we can just substitute in to compute this part, which is the spread. Since it's the most complicated part, we're going to go ahead and do that first. And so we know that P1 hat represents the not the population proportion, but the sample proportion that were cured from the drug. So we have 210 patients divided by 300 will give us the proportion of those students. So I'm going to type in 210 divided by 300. Pardon me, that was my wonderful cell phone. I forgot to put it on mute. So then we type in 210 divided by 300. And again, 300 is the sample size, so we'll put 300 here. P2 is 211 divided by 325. So I'm just using the keyboard and hitting the slash key for the division symbol, and that's what's allowing me to type in those fractions. And so now we've had the calculator, the ALEKS transfer that formula for the spread into the calculator or the standard error. We'll go ahead and hit equals, and that'll give us a value, and we'll store that in the ALEKS calculator. When I hit clear, when I hit recall, you can see that it's still there, so that's way cool. So now we've had the one part of the three necessary to compute the confidence interval for population proportions. And so now we're going to put in the P1 minus P2, P1 hat minus P2 hat. So we have 210 divided by 300, that's for the fourth sample, minus P2, which is 211 divided by 325. You could put these in parentheses, however the computation will be the same because order of operations will do the multiplication first. So even if you don't put the parentheses, you'll still get the right answer. Again, we're going to use the z, and you said, well, Donna, how do you know that you're going to use a standard normal curve? We got to make sure those proportions work. So what I'm going to do is I'm going to open up Word so that you can see that indeed those proportions are all indeed greater than 5. Opening up Word, we can see here that if we take N1 times P1 hat, that's 300 for the sample size, and then 210 divided by 300, we can see that this 300 in the numerator and this 300 in the denominator will cancel, which will leave us with 210, which is greater than 5. And then they also ask us to check for the following case when we have the same creature, instead of N1 times P1 hat, they have N1 times P1. I wonder if I can copy this whole thing. I think we can. I'm going to try it. Yippee! Instead of having N1 times P1 hat, instead we have 1 minus that value. And then when we rewrite that, 1 minus P1 hat bar basically is the complement of that. So if you have 210 out of 300 that are cured, how many are not cured? Well, if 210 are cured out of 300, then 90 are not cured. And so again, we can cancel those 300s, and we're left with 90, and that's surely greater than 5. And in fact, those proportions are satisfied for the second population proportion as well. So we can indeed use the z-test. So let's go back to Alex and do just that. Again, so we're going to go in, we have here the estimate, which was P1 hat minus P2 hat, plus or minus the z-score. So we substitute in z here. We have a 90% confidence interval, so that means 10% is in the tails. And when we divide 10% by 2, we get 0.05. I'll tab out, and then I'll multiply that times the spread, which we've already stored, so I'll hit the recall button, and there we have it. So we have the estimate plus or minus the critical value. In this particular case, it's going to be the z-score because it satisfied those products, making sure that the number of success being cured and the number of not being cured has to be greater than 5. And so when we hit the equal sign, we have those two values. And they want us to round to 3 decimal places, so let's go ahead and enter those values. So we have a negative 0.011, and then we also have a positive 0.112. Yippee, don't you just love that? So let's just do one more. Here we have a 95% confidence interval, and we have a random sample of 300 women from the first country. That 63 had nutritional anemia, and then 82 out of 250 had nutritional anemia. So let's go ahead and go to list of formulas so we can compute the spread, store it, and then we can go ahead and compute the confidence interval. So we'll scroll down to P1 minus P2 and click on the formula, which sends it to the Alex calculator, and then we can substitute in. So 63 out of 100, excuse me, out of 300. And then 82 out of 250. And that will give us the spread. So we'll store that value, and then we know that again it's 63 divided by 300. We'll tab out, minus 82 divided by 250, plus or minus the z-score, which is the critical value for the 95% confidence, is 0.05 divided by 2, or you can put in 0.025, times the spread. So we'll hit recall, and there's our spread. We hit enter, and it gives us the two values. and they're both negative, that's great. So that means the proportion is going to be somewhere between a negative 0.19 and a negative 0.04. We're 95% that the population difference, when we subtract those two proportions, will be negative. There's a 5% chance we could be wrong, that we won't capture, that this particular interval won't capture the true difference. And since the difference is negative, that means when I subtract two things and get a negative answer, then the first value, the first proportion, must be smaller. For example, 2 minus 7 is negative 5. The first value is smaller. So in this particular case, the first proportion is less than the second proportion. And we're 95% that the difference is going to be somewhere between 0.20 and negative 0.04. So let's go ahead and put those in. Negative 0.192 and then a negative 0.044. And let's make sure I round it correct. 0.192, go to 3, one more, yes. Yippee! Our favorite thing. Very good. So thank you so much. I hope this movie was helpful. Feel free to call me at 916-813-9027.